our galactic neighbor, a cosmic gulf. Look up at the night sky. On a clear night, you might see a faint smudge. That's Andromeda, our closest galactic neighbor. It's a spiral galaxy, much like our own Milky Way. Andromeda is beautiful, but it's also incredibly far away. How far? Imagine traveling at the speed of light, the fastest speed possible. Even at that incredible speed, it would take you 2.5 million years to reach Andromeda. That's longer than humans have existed on Earth. This immense distance presents a fundamental challenge to our dreams of interstellar travel. Andromeda is not just far, it's almost unfathomably far. Our current spacecraft are like rowboats compared to the vast cosmic ocean we need to cross. To reach Andromeda, we need a completely different approach to space travel. We've all seen rockets launch into space. They are powerful machines, propelling us beyond Earth's gravity. But even our most advanced rockets are woefully inadequate for interstellar travel. Chemical rockets work by burning fuel. This creates thrust, pushing the rocket forward. But to reach even the closest stars, we would need an astronomical amount of fuel. More fuel means more weight, and more weight means needing even more fuel. It's a vicious cycle. Today's rockets could get us to Mars, maybe even to Jupiter or Saturn. But Andromeda? That's a journey for a different kind of spacecraft. We need revolutionary propulsion systems, something that can achieve speeds far beyond what we can imagine today. Einstein's theory of relativity tells us that nothing can travel faster than light. Light speed is the ultimate speed limit in the universe. So why not just travel at the speed of light to reach Andromeda? While it sounds simple, there are major problems. First, accelerating a spacecraft to anywhere near the speed of light would require an unimaginable amount of energy. We're talking about the total energy output of the Sun for centuries. Second, even if we could reach those speeds, time itself would work against us. This is called time dilation. As you approach the speed of light, time slows down for you relative to someone on Earth. You might experience a short trip to Andromeda, but back on Earth, millions of years would have passed. So even if you could return, everything and everyone you knew would be long gone. The limitations of conventional physics have led scientists to explore theoretical concepts. These ideas sound like science fiction, but they offer tantalizing possibilities. One concept is the warp drive. Imagine warping space-time itself, creating a bubble around your spacecraft. You wouldn't actually travel faster than light within the bubble. Instead, you would bend space-time to shorten the distance between your starting point and your destination. Another idea is the wormhole. Think of it as a shortcut through space-time, connecting two distant points in the universe. Theoretically, you could enter a wormhole near Earth and emerge near Andromeda, bypassing the vast distance between them. However, both warp drives and wormholes remain highly speculative. We don't know if they're even possible, let alone how to create them. They would require manipulating gravity in ways we can barely comprehend. Given the challenges of light speed and exotic propulsion, some scientists have proposed a different approach: generation ships. These would be massive self-sustaining spacecraft designed for multi-generational voyages. Imagine a vast ark carrying thousands of people. It would need to be a completely self-sufficient world, with its own ecosystems, agriculture, and even artificial gravity. Generations would live and die on board, with only their descendants reaching the destination. Generation ships present their own set of hurdles. The technical challenges of building and maintaining such a vessel are enormous, and there are ethical considerations. Is it fair to subject generations to a life confined within a spaceship, traveling to a destination they may never see? Let's assume for a moment that we could overcome the technological hurdles of interstellar travel. We would still face a fundamental problem: energy. Propelling a spacecraft across such vast distances requires an immense amount of energy. Even if we discovered a way to achieve near-light speed, the energy requirements would be astronomical. Where would this energy come from? Some theoretical proposals involve harnessing the energy of antimatter or creating black holes in a controlled environment. But these concepts are far beyond our current capabilities. The energy challenge alone highlights the daunting nature of interstellar travel. It's not just about building a faster spaceship, it's about finding a way to power it. The journey to Andromeda wouldn't be a leisurely cruise. Space is a harsh and unforgiving environment. One of the biggest dangers is cosmic radiation. Unlike on Earth, where our atmosphere shields us, space is teeming with high-energy particles. Exposure to this radiation can damage DNA, increase cancer risk, and lead to other health problems. Then there's the vacuum of space itself. Without a protective atmosphere, even a tiny breach in a spacecraft's hull could be catastrophic. The void would suck out atmosphere and expose passengers to the deadly cold and vacuum. These challenges underscore the need for robust life support systems and radiation shielding on any interstellar mission. We would need to create a safe haven within our spacecraft, a miniature Earth capable of protecting us from the perils of deep space. Einstein's theory of relativity introduces a mind-bending concept: time dilation. As you approach the speed of light, time slows down for you relative to someone who is stationary. This means that time would pass differently for those on board a spacecraft traveling at near light speed compared to those left behind on Earth. Years on the spacecraft could be centuries or even millennia on Earth. This creates a strange paradox. While the travelers might experience a relatively short journey, they would return to an Earth vastly different from the one they left behind. Their loved ones would be long gone, and civilization itself might be unrecognizable. Time dilation adds another layer of complexity to the idea of interstellar travel, highlighting the profound disconnect that could occur between those who journey to the stars and those who remain on Earth. Even if we could overcome all the technological and environmental challenges, a fundamental question remains: can humans survive such a journey? Space travel takes a toll on the human body. We evolved under the conditions on Earth, not in the weightlessness and radiation of space. Long-duration spaceflight can lead to muscle atrophy, bone loss, and cardiovascular problems. There are also psychological challenges to consider. Confinement, isolation, and the stress of long-duration spaceflight can affect mental well-being. Maintaining morale and purpose on a multi-generational journey would be crucial. Overcoming these human limitations would require advances in medicine, psychology, and our understanding of how humans adapt to extreme environments. We would need to create a spacecraft that is not just a vehicle, but a self-contained world capable of sustaining human life for generations. The prospect of traveling to Andromeda may seem like an impossible dream, and right now it is. But throughout history, humans have pushed the boundaries of what's possible. We've gone from the first hesitant steps on the Moon to rovers exploring Mars. We've built the International Space Station, a testament to international collaboration in space. The journey to Andromeda would require breakthroughs in propulsion, energy, material science, and our understanding of the universe itself. We would need to harness the power of the stars, manipulate the fabric of space-time, and perhaps even discover new physics. While we don't have the technology today, it's not beyond the realm of possibility that future generations might unlock the secrets of interstellar travel. History has taught us that what seems impossible in one era can become reality in the next. For now, the journey to Andromeda remains a distant dream, a testament to human ambition and our fascination with the cosmos. The challenges are immense, but so is the potential reward. Imagine standing on a planet orbiting a star in the Andromeda galaxy, gazing back at our own Milky Way as a distant spiral in the sky. Such an achievement would mark a new chapter in human history, expanding our horizons beyond anything we can imagine today. While we may never set foot on a planet in Andromeda, the pursuit of this dream drives innovation and inspires us to push the boundaries of science and technology. It reminds us that we are part of something much greater than ourselves, and that the universe is full of mysteries waiting to be unraveled. So the next time you see that faint smudge of Andromeda in the night sky, let it be a reminder of the vastness of the cosmos and the boundless potential of the human spirit. The journey to the stars may begin with a single step, but it's fueled by the enduring power of human curiosity and our relentless drive to explore the unknown.